Hi, in this video we're going to look at a special type of simplification process, and this occurs when you wind up with a radical in the denominator of your fraction, and this happens quite often. So what you want to do is you want to multiply this by a form of 1, and this procedure is called rationalizing the denominator. And the form of 1 is always going to be the actual radical that is in the denominator. So since the square root of 2 is in the denominator, I'm going to place that over itself, and you can quickly see that that is a form of 1. When you multiply anything by 1, you get that number itself, and this just gives us an equivalent answer to that. So when I multiply 2 times the square root of 2, that's what I get. I do not want to multiply the 2 and the 2 because one is inside the radical and one is outside. And then the square root of 4, which simplifies down to equal 2. And then you can see from this 2 over 2, that will cancel out because they're equivalent factors, and my final answer is the square root of 2. Let's try another example. In this example, my form of 1 is going to be the square root of 3 over 3. And I also want to note that the square root of 4 is a perfect square. So you can actually trade that square root of 4 out for a 2, and that's going to be times the square root of 3. 3 times 3 is the square root of 9, which we know is equal to 3. So our final answer is 2 times the square root of 3 over 3. Let's do another example. In this example, our form of 1 is going to be the square root of 2 over the square root of 2. And 3 times 2 is the square root of 6. And 2 times 2 is the square root of 4, which is equivalent to 2. And that would be your answer. One more example. In this example, we have some adding and subtracting going on in the numerator, which is fine because all we have to do is once again multiply this by a form of 1, which is going to be the square root of 12 or the square root of 12. And we will distribute this 12 to these two terms right here. And when we do, we're going to get negative 4 times the square root of 12 minus the square root of 36. And that's going to be over the square root of 144, which we know is 12. Now we can do a little bit of cleaning up in that numerator. First of all, we know that 36 is a perfect square. We also have a perfect square hidden in the 12. So let's just break that 12 up into 4 times 3. And let's just switch out that 36 for a 6. And let's continue this process. The square root of 4 is equal to 2, and 2 times 4 is negative 8. So it's going to be negative 8 times the square root of 3 minus 6 over 12. And then as you can see, each one of these terms shares a common factor of 2. I can actually factor a 2 out of that numerator. And now you can reduce that 2 with this 12, and that gives you 6. Now another thing you could have done on this problem is you could have actually started by simplifying out the 12, but we'll look at that at another time. And so this one again, our form of 1 is going to be the square root of 19 over the square root of 19. It's called rationalizing the denominator again. And this gives me 5 times the square root of 19 plus the square root of 38. I'm going to put that all over 19. And that would be my final answer. There's nothing that I can possibly do to simplify that anymore. Okay, so this one's going to be the square root of 6 over the square root of 6. And when I distribute this square root of 6 to both these terms, I'm going to get 4 times the square root of 6 plus the square root of 18 over the square root of 36, which is 6. Now, we can simplify the square root of 18 because it does have a perfect square factor in it. And that perfect square factor is 3. Excuse me, it's 9. 9 times 2. And that gives me the 4 times the square root of 6 plus 3 times the square root of 2 over 6. And I do want to just point out the fact that you cannot add the 6 and the 2 together because they're not like radicals. In order to combine, you must be the same kind, and those are not the same kind. And that does conclude this video.